Ladies and gentlemen, we did it. After nearly a year of work, thousands of dollars spent, and countless screw-ups and dead ends, I can now officially say that I am able to recycle my failed 3D prints, supports, and multicolor poops into usable, consistent filament. Filament that works on nearly all of my printers, even those with a 0.4mm nozzle. And not just prototyping filament either. Filament that is good enough to use for normal, everyday printing of functional parts. And in this video, I'm going to tell you how we got here, the hurdles I had to overcome, how I could have saved time and money, and what I learned, so that you too can decide if this is a path you want to go down. Let's get after it. Now, technically, this is the 6th video in this series. I'll go ahead and link the playlist below if you want to come along for the entire journey or catch up, but I'll also do my best to catch you up as we go along or fill in those of you who haven't seen every single video. When we last left off, I was finally able to create reasonably consistent filament, albeit filament that clogged pretty frequently, and which had a kind of cool but unintentional transition effect to it. At the time, I thought that by simply improving the cleanliness of my regrind, I would soon be able to create even more consistent filament that didn't clog. I honestly had no idea what was waiting for me. The first thing I did was to make some improvements to the shredder. These included creating a funnel to allow only shredded plastic into the bin, isolating any wood chips or welding slag from my poorly constructed frame from falling into the bin at the same time. I also added a powerful CPAP fan to the top of the shredder to help expel heat and sufficiently shredded regrind from staying past its welcome. Technically, I already covered these upgrades in a video outside of the series, which was about designing 3D printed solutions for real problems, but I didn't do an actual video in this series about it. And I guess that's kind of a good thing because both those things largely ended up being dead ends. You see, one of the biggest issues I was having, besides of course contamination, was overheating, hence the fan. But over the course of months of testing, I came to realize that it wasn't going to be as simple as just expelling the heat with a fan. In reality, while a lot of the heat is generated by the friction of shredding material, a large portion of it is actually being generated by the shredder itself, which is still rubbing up against itself and creating metal shavings, and a ton of heat in the process. I'll cover how I'm dealing with those metal shavings in just a minute. For now, as far as the heat goes, I haven't been able to permanently and sufficiently solve it. I've taken apart the shredder more times than I can count. I've rearranged the blade pattern, I've moved blades further up the drive shaft, and none of these fixes have lasted more than a few days. But my hope is that eventually the shredder will kind of break itself in. It'll grind away all the offending material and maybe operate more smoothly. Another cause of heat was the sieve size. You may recall that this design, the Precious Plastics Shredder 2.1, comes with an 8mm sieve, and that was simply too big for the ArtMay extruder that I'm using. Previously, I'd ordered multiple replacement sieves from PCBWay, who, by the way, is the sponsor of this video, in both 4.5 and 5mm hole sizes, and I'm very glad I did. I started out with the 4.5mm one, and that was causing way too much material to build up in the shredder, which would then churn, trap in heat, and clog the shredder entirely. Fortunately, I was able to hand cut some steel plates and recreate the sieve using the 5mm mesh that they created for me, but I unfortunately found out that the steel I'd used for the side panels was not hard enough, and it completely bent when I tried to screw it into the actual shredder. So I'll be ordering replacement parts again from PCBWay, this time in the right steel. Actually, I was planning on making my own replacement parts to make another sieve now that I have a Carvera Air CNC here. But it turns out that it's really hard to find someone who will sell you a small amount of 3mm thick stainless steel sheet. Like, I can easily find someone who's willing to sell me a 2 by 2 sheet if I'm willing to pay a king's ransom for shipping. But what the hell am I supposed to do with that much stainless steel? I don't think I can even get it down the stairwell here. That's why for things like this, even if you literally already have a perfectly good CNC in your shop, it's often much easier and even cheaper if you consider the investment of purchasing such a huge amount of stainless steel to just order what you need from PCBWay. They can CNC machine or plasma cut or 3D print just about any material you need, from stainless steel to different kinds of plastics to resin, titanium, all for a great price and with quick turnaround. They also have engineers go over every single order to ensure that there won't be any issues during manufacturing. You can check them out using the link in the description and get $5 off your first order today. As you can see, I finally just gave up trying to find someone to sell me a small amount of 3mm stainless and ended up ordering the parts from PCBWay. Plus, I think I'm also going to experiment with a 2-stage shredding process where I shred the material down to 8mm chunks first, swap out the sieve, and then shred it down to the 5mm or 4.5mm chunks. But while I wait for those parts to arrive from PCBWay, I'm fortunate enough that even though the sieve is kind of dangling in there, for now, it works quite well, and you can see that I'm finally getting really nice uniform regrind. And as you'll see in a bit, that is a huge part of getting high quality filament. Another thing I've experimented with in order to get higher quality filament is virgin material. I found a local high-performance polymer composition company, Plastics App, who's willing to sell me some of their virgin high-performance PLA pellets in really small quantities. However, this combined with the fact that it isn't just plain Jane PLA meant that it was really expensive. After shipping and taxes, the latter of which I do get back as a business, it ended up costing me about $28.57 per kilo for these high-performance PLA pellets, which is about 2 times as much as finished filament should cost. Nonetheless, I decided to go ahead and buy it just for experimentation purposes. I figured that if it makes a really big difference, I could later buy normal PLA in bulk, potentially from a different supplier for much cheaper. I ran some experiments with 15 to 20% virgin PLA, and the first runs were honestly disappointing. Pockmarked filament that wouldn't give me a consistent diameter. Something was still wrong with my regrind, and I wasn't sure what. It was at this point that I started really experimenting with how I was treating and processing the regrind. After all, David, the creator of the ArtMay extruder, repeatedly points out in his guide that this really is one of those garbage in, garbage out type processes. And there were numerous ways in which my regrind could potentially be garbage. First, I added a stack of magnets into the ArtMay's agitator, which now spin around and capture any metal shavings or fragments that might be in the filament. And let me tell you, does it capture a lot. This modification has been so successful that I actually recommended it to David to add it to the product itself. Though I will say that even after increasing the melt filter in the ArtMay to 0.6mm, I still am not able to actually use a filter when extruding on the ArtMay. Anytime I add a melt filter before the nozzle, it clogs up after just a few meters, and I can never get the filament diameter right when it's installed. Fortunately, as you will see in a second, that turns out to be a non-issue. Additionally, and perhaps more importantly, I changed the way that I was preparing the material for extrusion as well. Whereas in the past, I was washing it to try and get rid of any errant dust, I stopped doing that altogether, partly because the stuff that I had washed ended up molding over, which ruined kilos and kilos of perfectly good regrind. But what's more, I started to realize that there was no way that my filament was this contaminated. There was no way that all of these little pockmarks were just dust and contamination. But what else could it be? After all, I was drying my regrind in an oven at 60+ degrees Celsius for 6, sometimes 12 hours to try and get out all the moisture. And the pockmarks appeared whether or not I washed the regrind. It was at this point that I happened upon a video by my fellow YouTube creator, Igor from MyTechFun, which would pretty much change my life. That might sound like an exaggeration, but seriously, 3D printing as a whole, especially filament recycling for 3D printing, has been so much more enjoyable and easier since I saw this video. In the video, Igor tests the feasibility of drying various types of filament in a microwave. I know, it sounds ghetto, dangerous, irresponsible, sus, but it works. Like, really works. A handful of rounds of 30 seconds on, 5 minutes off in a microwave, and you can literally feel the humidity coming off of the filament. Just look at this. On the left, we have filament that was dried in an oven 2 times for 6 to 8 hours each time. And on the right, we have filament that was dried in a microwave for a handful of rounds of 30 seconds. Can you say breakthrough? This method works so well that I've actually connected the microwave oven here in the studio to Home Assistant, and I created an automation that I call drying protocol. It does 5 cycles of 30 seconds on, 5 minutes off to completely dry the filament in under 30 minutes, without me needing to babysit it or worry about the microwave melting it or worry about the oven starting a fire in my studio. And just look at the results. Look at this gorgeous recycled filament. It was this one change, properly drying the filament, that made all the difference. I was now able to do long prints, like 6+ hour prints, of course, using a 0.8mm nozzle with almost no issues. But occasionally, and particularly with my black filament regrind, I was still having some issues. Eventually, by examining the area at and before the clog, I realized that it wasn't clogs at all, but in fact, it was filament jams. Simply put, my filament was becoming too wide or bumpy at certain points, and that would get jammed in the extruder or hot end. But why? I stood on this problem for days, printing only on printers that had smart filament sensors and jam detection, until one day it hit me right in the nose. Literally. I was grinding up some black PLA into a nice big bin to extrude into a new spool of filament for an upcoming project. I nonchalantly threw in a piece of a 3D print that I no longer needed, and about 10 seconds later, my heart sank. The room quickly filled with a pungent but all too familiar odor, ABS. I had just irreversibly contaminated something like 10 kilos of material. But worse than that, I instantly realized what had been causing those blobs in my previous attempts. Somewhere along the line, I had contaminated my material, probably with ABS. It's hard to overstate how demoralizing this was. I had spent the better part of a year, thousands of dollars, and hundreds of hours of my time building this rig, separating my materials, shredding filament, collecting all my regrind into bins. And now I had around 20 kilos in total of completely useless material that would end up in the landfill anyways. I was honestly devastated. What was I doing spending so much time on this project when I didn't even know if it was going to be successful in the end? I seriously considered giving up the entire project, tossing all of the material that I'd collected over the last 3 years straight into the bin and just moving on with my life. Fortunately for me, the universe, God, the flying spaghetti monster, or whoever saw how demoralized I was because he, she, it, they sent another challenge my way. A challenge which would get me back on the horse. So due to logistical issues during the holidays and the war here in Israel, my huge shipment of Polymaker filament, which I desperately needed in order to make progress on that upcoming project, well, it didn't show up. Month after month went by, and for some reason, bupkis. I burned through every last shred of black and white filament, both here and at home, and I was completely dry. And at this point, I needed to be able to print things normally, not just on a 0.8mm nozzle. Things got so bad that I was printing PLA support filament for non-critical parts. In a moment of desperation, I turned to the 3 or 4 imperfect spools of recycled filament that I had made before the fiasco, and I thought to myself, what do I have to lose? I loaded them into the IdeaMaker IR3 V2, which I only have a 0.4mm nozzle for, and I hit print. What happened next kind of shocked me. It just worked. I mean, sure, every 4 or 5 hours, the smart filament sensor would trigger due to a jam, and sure, you could literally see the flecks of dust and metal shavings in the prints, but it was printing, like, beautifully. No stringing, no under extrusion. It was just printing on a 0.4mm nozzle, and the parts were dimensionally accurate. Emboldened, I started printing with the black filament on some other printers, and to my surprise, those worked too. In many cases, the parts were actually indistinguishable from virgin PLA. I was back, baby! I decided to put aside all the contaminated material for another project, maybe an epoxy table or something like that, and get back on the horse. I printed nearly 3 kilos of parts for that upcoming video, all with minimal jams and almost no clogs. I had done it, and boy, what a journey. Now, that isn't to say that I'm home free. I still have a lot of areas that I can improve. Like I said, the shredder is still heating up, causing it to occasionally spit out a kneaded, melted together clump of filament that I then need to manually remove. And I'm still struggling somewhat with black material being bumpy, to the point where I'm not sure if the black filament is just maybe more hygroscopic than the white stuff, or if I still haven't managed to get out every last bit of ABS contamination from the shredder and the sieve. What's more, I still suffer from pretty frequent jams if I don't load the shredder very, very gradually. So as I mentioned before, I definitely do want to still experiment with a two-stage shredding process when I get those parts from PCBWay. And lastly, I'd like to get to a point where I don't have literal metal shavings in all of my filament, either by wearing the shredder down or by coming up with some kind of permanent fix for the friction. So if you have any ideas, please do share them in the comments below. With all that said, we're pretty much there. At times, many times admittedly, it felt like we would never make it. Like this would become just another project that never makes it past the 80% mark. But I am so proud of the progress we have made. And I literally couldn't have done it without all of you guys, whether it's local subscribers who helped me fix my screw-ups, or the thousands of helpful comments and suggestions that you guys left to guide me along the way. This really does feel like a communal effort, so thank you guys. And as such, because the whole idea behind this was for me to walk so that this entire community could run, I want to now bring it back and highlight some of the lessons that I've learned, particularly since the last video. For the sake of convenience, in case anyone is coming back and using this part of the video as a reference in the future, I will stick to kind of bullet points for each lesson rather than burying them in the story part of the video that we just got through. Lesson number 1, be ruthless in material isolation and sorting. The first and definitely the most painful lesson that I've learned in the last few months is just to be absolutely ruthless in sorting your material. Obviously, if you go down this path, you care a lot about recycling and saving material from going to the landfill. So it hurts to throw out perfectly good parts. But in the end, it is so much better to throw out one part than an entire bin of shredded material due to contamination. If there's even a 1% chance that the part is ABS or PETG, take it from me and just throw it in the trash. If there might be glue or other contaminants on or inside the part, throw it out. It's just not worth it in the long run. Lesson number 2, shred into smaller bins. But of course, there will be mishaps, especially if you, like me, aspire to accept waste from other people. For this reason, I advise you to never shred into large batches. Shred into small bins and keep batches separate so that a contamination event like my ABS mishap doesn't result in you throwing away more than a kilo or 2 at worst. Number 3, forget about other kinds of contamination within reason. Earlier on in the process, I was really stressed about things like dust, dirt, and even sawdust contaminating my filament. So much so that I washed my filament shreds in water to get all of it out, only to cause even worse contamination in the form of mold. Obviously, you can't have large wood chips or sawdust in your regrind, but within reason, it's been my experience that dust and dirt aren't all that big of a deal. Sure, it would be nice to eliminate the metal shavings from my filament, but removing them after the fact with a magnet inside of the hopper has been working just fine. Number 4, ditch the melt filter. With that said, if you are working with slightly contaminated filament, you will likely need to remove the melt filter in your extruder altogether. Sure, this means that debris will slip through the nozzle and into your filament, but from my experience so far, you'll get far fewer clogs on the printer itself than you will the extruder, which uses the melt filter. So I would forgo the melt filter altogether. Number 5, choose the right 3D printer for recycled filament. With all that said, your recycled filament is definitely never going to be perfect. At least I certainly haven't found a way to make it so. For that reason, I would advise being choosy about which types of 3D printers you actually run the recycled filament on. For one, I would advise against running it on any printer that doesn't have a smart filament sensor capable of detecting clogs or jams. But those are cheap and readily available to add to your Clipper printers, and most of the higher end printers these days are coming with them standard, so that's not too big of a limiting factor. Additionally, while you might think that it's the nozzle size that is going to dictate whether or not you can print recycled filament, I actually found that some extruders are more forgiving than others when it comes to diameter variations of recycled filament. Printers which have 3D printed components at the extruder, such as a Prusa or a Voron machine, tend to be more forgiving, whereas something like a Bamboo Lab printer, which has a very tight tolerance on the all-metal entrance to the nozzle, will likely jam much more easily. Experiment with the different printers at your disposal, or consider building a new tool head using something like the Orbiter and 3D printed tool head designs if you're serious about printing recycled filament. Lesson number 6, build a filament pelletizer. No matter what you do, no matter which printer you try to use, you are inevitably going to end up creating a lot of unusable filament should you go down this path. For this reason, I do suggest that you build a filament pelletizer early on in your journey to help you reconstitute that useless filament back into useful regrind that you can actually extrude. You might think that you could just use the shredder that you built to regrind up that filament, but unfortunately, a shredder is ultimately going to let a lot of large and long strands of filament through the sieve. So really, the only way to reclaim that imperfect filament is to go with a pelletizer. I've been using this free and open source design by Michael Laws from Teaching Tech, though I am definitely still in the process of upgrading it to hopefully run by itself without the need for me standing there and holding a drill. Going forward, I would definitely consider some form of pelletizer to be a required part of this setup or ecosystem. And lesson number 7, which is shredder sieve size and heat dissipation. Again, as I mentioned before, I am definitely not home free when it comes to a reliable shredder setup, but so far, what's been working for me is having a 5mm hole grid in the sieve combined with a high-powered CPAP fan for cooling. I'm pretty confident that the heat buildup to one side is the result of improper alignment on my shredder drive shaft or the individual blades being pushed too far to one side. But quite frankly, I'm not taking it apart and rebuilding this damn thing a 6th time, so it will have to do this way. All in all, I do think that the precious plastic shredder, if modified accordingly, can work for this type of application, and I also do look forward to experimenting with a 2-stage shredding process. So let me know in the comments below if you'd like to see yet another video in the series once I've had time to do all of that. Anyways, those are the major lessons and takeaways that I have to share at this point. Add them to the long list of wrong turns, screw-ups, and costly mistakes that I made along the way, which are all covered in detail in videos 1 through 5. For now, I'm excited and energized to keep tuning, tweaking, and improving my filament recycling process. And before you say it, no, this probably isn't cost-effective either in time or money for the average hobbyist. And yes, it is cheaper and easier to just buy virgin material, but that was never the point. Over the next few years, it is my sincere hope to save hundreds or even thousands of kilos of material from the landfill, both by personally recycling them here or by inspiring others like you to pick up where I left off and build their own 3D print recycling projects. So let's keep the discussion and the momentum going, either in the comments below or on our Discord server, where we've set up an entire recycling channel just for stuff like that. Guys, thanks again for watching and supporting me through the ups and downs of this entire journey. It really has meant the world to me. That's all for this week, but I'll see all of you on the next layer.